Okay, so this time decided to go to the Numinbah Valley. So this is the big explosion. So that's where are we here? That's Redcliffe and that's Brisbane. That's the Gold Coast. And that's New South Wales. And so there's that big explosion. And the Nerang River, this is Numinbah Valley, and the Nerang River's down here. And then it goes off into Hinds Dam. So this is Numinbah Valley. The Nerang River is just there, and there's these Rhyolite cliffs. So I was just curious, can you just look at a river and then be able to tell the local geology? So I think you can have a general guess. This is North Pine River, where they're just mainly the blue metavolcanics, metabasalts, and the brown I forget what it is, the metasedimentaries, pelex or whatever they're called. And you can't really see any whites. Now, when you do see whites, it's quartz. So that's the South Pine River, Upper South Pine River. So you can't see any greenstones here. And this is the Nerang River, near where those rhyolite cliffs are. And you can see that they still have the blues and the browns, but there's a lot of whites, and they're not quartz. And if you have a careful look at the whites, they're rhyolite. Um, so I dare say if you put me on, blindfold me, put me on the Nerang River and put me on the South Pine River, I'm going to tell you, I'm going to be able to tell you which river I'm on. All right. So this one doesn't have rhyolites and this one does. So that was one of my goals. Now, my second goal was to be able to just look at a road cut and know what the rock is, and I definitely discovered I can't do that one. The one thing I did notice that everything looks brown, and I kind of assumed everything was basalt. And then when you take a closer look, everything's got a brown covering because no matter what it is, it's got some sort of iron weathering on the outside, and you have no idea what's on the inside. Although that one doesn't look very brown, but these three did. So can you guess? Can you tell me what sort of rocks these are? I'll go through them. So I found out you really got to go up close. You've got to get out the little by 8 magnification, and you can see that that one is actually sandstone. You can tell it's crumbling a little bit more than the rest. That's a little bit of a clue, and it sort of is coming off in sheets, and you can see layers a little bit. So there are some other clues, so maybe it is possible. This one I thought was basalt because it was quite blocky, but inside you can see it is a sandstone. So those two are sandstones. Now, this one I thought could be a sandstone. I didn't know what it was after that. Um, but you can see that I think it's actually a rhyolite. Is it because of the texture? It's fine grained. I think it's got that greeny blue color because of the copper. Because there were chalcopyrite crystals, and you can tell it's not gold. Fool's gold. One of the features between gold and pyrite or chalcopyrite is it gives off these little color reflections. You can see some iron red staining there as well. And so that would be a rhyolite, an unusual one. And then this one finally was the basalt with the fine grained dark matrix. So I think, yeah, maybe with time I can just look at it and tell. I just need a bit more practice. All right. Going back to the North Pine Dam, remember I said that the council had taken all the boulders out and wrecked the river, made it just some muddy thing. And so Nerang is actually in Springbrook National Park and it's been protected, and this is exactly how it used to look. So I have
Okay.
actually something quite accurate to compare it to. It looked just like that. So I'm just going to go over some key features of the rhyolite. So the rhyolite is pretty much like granite. Like granite cools slowly, intrusively, and rhyolite it cools very quickly, extrusively. So it's a very fine matrix, and it has a light color as opposed to basalt versus gabbro. This is like rhyolite versus granite. And so, as you can see, it's high in silica, has a very light color. You can tell when the phenocrysts don't line up that they're all in different directions, that must be an igneous rock, and they just formed in all different directions. They weren't pressured into forming layers, such as metamorphic or igneous, or even the basalt after it's been gone under some metamorphosis. Um, and this one doesn't have the banding. It doesn't has a few bubbles here, but there's way better examples. It does have the phenocryst, large crystals in the matrix, and so that has enough of the key features to recognize it as rhyolite. Notice it's a bit brown. You'll notice that pretty much every rock is a bit brown, and when you look inside, you have to look inside the rock to really know. So I was going to call this brown rocks, but I didn't think that was fair, so I didn't call it brown rocks. This one was split in half. I did not do that. And it was just sitting in the water like that, exactly like that. And so I took a picture of it. You can see there's quartz crystals in there, high silica content, fine matrix. Um, Moving on. This is brown on the outside, but I'm sure it would be white in the middle. It's just huge. Could have been a lava bomb, so it was ejected into the air with all the gas bubbles on it, and then it landed. And so it is very has a lot of gas bubbles, vesicles. And this one shows the banding quite nicely. You can still see the phenocrysts, the crystals in the fine matrix and vesicles. And because it's so viscous, it flows over and causes this banding to occur. So up close, you can see all the little fine crystals as well. And so you can see here, you can see the banding that it has here, plus the vesicles. It is a little bit whitish, although it could have been brown, depending on what side it was. And lastly, you can see the banding along here. You can see the vesicles. You can see that it is a lighter color. And so I haven't gone in close enough to see phenocryst, but you can actually see it on this particular rock, even at this distance, and you can see the banding on this one. And so that's all the key features, so you know it's rhyolite. And it's probably basalt because it is a blackish color, but most of them are brown, have a brown iron on the outside. You really need to have a look inside for most of them, but some of them, like these two, they're probably obvious, just enough to say that's basalt, and it's a rhyolite.